in the diagram below, measure of angle 1 is 16x minus 9. The measure of angle 2 is 45. The measure of angle 3 is 6y plus 15. And we want to find the values of x and y. So typically I like to start with vertical angles first because I think that vertical angles might be a little bit easier to work with than linear pairs, but in this particular case, angle 1 is vertical to angle 3, and angle 1 has an x in it, and angle 3 has a y in it. So we can't solve that yet. So we're going to go back to our linear pairs. Angles 1 and 2 are linear pairs. So if we take angle 1 and we add it to angle 2, so 16x minus 9 plus 45, linear pairs add to be 180. We get 16x plus 36 equals 180. We combine like terms. Negative 9 plus 45. We're going to subtract 36 from both sides. And we get 16x equals, got to put the x in there, 16x equals 10 minus 6 is 4, 144. So when we divide both sides by 16, we're going to get x equals 9. And now that we know that, we can use vertical angles to help us find angle 3. We could use a linear pair to help us find angle 3. So there's a couple options. I am going to use vertical, and I'm going to look and see if I've got a better color here that might show up. But angle 1 and angle 3 are vertical. So when we're working with vertical angles, opposite angles, we know that those are equal. And what we also just found out is that x is 9. So we can put that value of 9 back in here for x. So this is really 16 times 9 minus 9 equals 6y plus 15. That allows us to write this equation in one variable. So just a reminder here that 16 times 9 is 144. If you need to, type that into Desmos. And 144 minus 9 is 135. And we are trying to solve for y. So we will subtract 15 from both sides. And we get 120 equals 6y. And then when we divide both sides by 6, we end up with y equals 20.